Hey Chem Kids, Campbell here. In our next unit, we're going to be studying chemical reactions and chemical equations. In this video, we're going to be looking at some of the basics of chemical reactions. Like, what is a chemical reaction? Well, a chemical reaction is just when atoms in compounds or atoms by themselves rearrange and form different compounds. Well, how do you know if a chemical reaction has happened?
Well, one thing you may notice is fizzing. Which is the formation of gas bubbles, or maybe it burns.
So there are many ways to tell, because a chemical reaction is a chemical change. And maybe we get a temperature change like when we did the endo and exothermic lab. Maybe we get a color change like when we did that one lab with the copper and we put it over the Bunsen burner and it turned black. Maybe change of state, right? The same thing happened in that lab. Before we actually put it over the Bunsen burner, we saw two liquids form a solid. Maybe odor, if it starts to smell funny. Or gas bubbles. Or maybe something burns. So if it's a chemical change, there's a chemical reaction. Now, chemical equations are used to represent chemical reactions. So we use chemical symbols or chemical names, and we show reactants, which are the substance we start with, on the left side of the arrow. And by the way, the arrow means yields. And the products are on the right side of the equation. Those are what we end up with. So reactants form products. Now, some symbols that you need to know as they apply to chemical reactions are these. So make sure you write these down in your notes. When you see a plus sign, we just use that to either separate two reactants from each other or two products from each other. So it's not like we're adding them. It's just a way to separate them. The arrow, remember I said, means yields, and we use it to separate the reactants from the products. Other things that you're going to see in chemical reactions are these little symbols. And what these symbols tell you is the state of the substance in the chemical reaction. If you see AQ, what it means is the substance has been dissolved in water. If you see S, it means our substance is a solid, kind of like the magnesium ribbon I just burned. Or maybe the L would mean that the substance is in a liquid state, or G would mean that the substance is a gas. So make sure you remember those because we write them into chemical reactants. So when you see a chemical equation, besides seeing the chemical symbols or the names, you'll also see these little symbols to indicate what state of matter that reactant or product is in. Now, one other thing before we talk a little more about some chemical equations is when you write a chemical equation, there are certain elements which always are found in pairs. So when we write them in a chemical reaction, if it says hydrogen, we don't just write H, we write H2. These are called diatomic molecules, and there are 7 of them. So there's hydrogen, which is in the top, right, the top left of our periodic table. And then if you notice the other ones, we have oxygen and nitrogen, fluorine, chlorine, bromine, iodine. If you look, they actually form the number 7 on your periodic table. Kind of freaky. There's nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Notice that most of these are halogens. But anyways, if you see chlorine gas in a reaction, you're going to write Cl2 with a little sub G, not just Cl. So let's take a look at what I mean by this. So say you have to write a chemical equation for this reaction. Hydrogen gas reacts with oxygen gas to produce liquid water. Well, I'm not going to write just H because hydrogen doesn't appear by itself. It's always H2, and it's a gas, so I need to use a little subscript G. So it would look like this. Here's my hydrogen, H2, gas, to symbolize it's a gas. There's my plus to separate my hydrogen from my oxygen. And again, oxygen is diatomic, so we have to put a little 2 there. And then gas. And here's my arrow for the produces, or yields. And here's my water, H2O. And it's liquid water, so I put an L. But notice that the hydrogen and the oxygen don't appear by themselves. They don't like to be alone. So any of these guys, when you read a statement that you have to translate into a chemical equation, if it's one of those, make sure that you write it as a diatomic molecule. So just not by itself, always put a 2 there when it's by itself. Okay, so let's take a look at this reaction again. Hydrogen gas reacts with oxygen gas to produce water. What's wrong with this chemical equation? I mean, hydrogen and oxygen are diatomic. I have my little gas symbols. Water is H2O. I don't see anything wrong with it. Well, until I start counting atoms. So equations have to be balanced, which means that you have to have the same number of each atom on each side of the arrow. So if I look here, I have 2 hydrogens on the left side, and I have 2 hydrogens on the right side. So hydrogen's good. But look at my oxygen. Here I have 2 oxygens, and here I only have 1. Not good. And now you may be thinking, but you know what? Well, let's just write 1 oxygen here. But you can't do that because oxygen's never by itself. So the law of conservation of matter says that atoms, right, are not destroyed in a chemical reaction. They just get rearranged. So I can't just write only 1 oxygen over here because I didn't lose an oxygen. It didn't go anywhere. It didn't get destroyed. That would violate the law of conservation of matter. So we're going to have to do what's called balancing of chemical reactions to make sure that the number of atoms on the left side in the reactant side is the same as the number of atoms on the product side. So in order to do that, we use something called a coefficient. So when we balance atoms, we use coefficients. And coefficients are just whole numbers that we put before a chemical formula. Never, ever change the subscripts. Right? The H2O, the little 2 there, or the O2, never change those. Those, remember, subscripts come from the actual balancing of charges in a chemical formula. So never mess with those. So if we want to take a look, just so you're clear, the coefficients are the big numbers that we can just arbitrarily put in front of the compound or molecule in a chemical reaction. The subscripts are these guys. Don't ever change those. You write the chemical formula based off the charge. Then we go back and we balance using the coefficients. All right, in class, we're going to learn how to balance chemical reactions. So I'll see you then.